Today we are covering section 2.3. In section 2.3 we put all of the equation rules together from section 2.1 and 2.2, and this will be the most difficult of the three sections. Your steps for solving equations are to make sure you simplify the expressions on each side. Once you've condensed them into the fewer number of terms, then you can get all of your variables on one side and all of your constants on the other. Once you do that, you can isolate the variable. In other words, you can get the variable by itself and solve it out. If you want to check, you can. I do not require that you check, but if you're a checker, you are welcome to check. So I want you to solve the equation, and the equation is lengthy. It's 3x plus 2 minus x equals 6 plus 3x minus 10. There are a good many terms there. So the first thing that we can do is simplify terms that are alike, and so that will condense the number of terms. For example, on the left side, I have a 3x and a minus x. Those two are same signs. So all I say is 3x minus x would give me a 2x on that side. The constant 2 I'll just bring down. They were on the same side, so I didn't change any signs. All I did was combine like terms. On the right side, I have a 6 and a negative 10. Those are both constants. The 3x stands alone. There's not another x term, so I'm just going to bring the 3x down. And 6 minus 10, they have different signs, so I'm going to subtract and take the sign of the larger, so I get a negative 4. Now this problem, 2x plus 2 equals 3x minus 4, is far easier to solve. What I need to do first is I need to get the x's on the same side. Now I'm going to choose to move this 3x, but you could have moved the 2x. Either way would have been fine. I know I've got to move the 3x over there to the other x, so when I move it I have to change its sign, and that gives me a negative 3x on both sides. So a positive 3x and a negative 3x add out, and 2 minus 3x would give me a negative 1x. My equation now reads negative 1x plus 2 equals negative 4. Remember, I'm only working on the x side, so I'm going to move the 2 first. I'm going to subtract 2 from both sides. So negative 1x would equal negative 4 plus negative 2. Those have the same sign, so I'm going to add and keep the sign, which would give me a negative 6. To solve it from here, I'm going to divide both sides by negative 1, a negative 1, and the top and bottom cancel, and x would equal 6. So my final answer for that problem was 6. My next problem is 10x plus 1 equals 2 times 3x plus 5 minus 1. What I have to do first with this equation is I have to distribute. So I'm going to distribute the 2 all the way through. I'm going to distribute the 2 all the way through the set of parentheses. So I get 10x plus 1 equals 6x plus 10 minus 1. Looking on the left side, 10x plus 1, those do not have any common terms. Looking on the right side, 10 minus 1 would combine. So I have 10x plus 1 equals 6x plus 9. Now I need to get the x's on the same side, so I'm going to choose to move the 6x. Since I'm moving the 6x, remember I have to change its sign, so this would give me a negative 6x on the left and right. 10x minus 6x is 4x. My equation now reads 4x plus 1 equals 9. To solve it from here, I'm going to move the 1. The opposite of add 1 is to subtract 1, so I'll subtract 1 from both sides, and 4x would equal 8. To get rid of the 4, I'm going to divide both sides by 4. A 4 in the top and a 4 in the bottom cancel, and so x would equal 2. This would be the hardest type of problem that doesn't have fractions from section 2.3. So let's grab ones with fractions. My first fraction equation that I have is 3/4 equals x over 12 plus 2. The first thing I'm going to do is turn all of the terms into fractions. So the whole number 2 will turn into a fraction if you put it over 1. The next thing I have to do is find a common denominator, just like we did in chapter 1. The common denominator for all of these denominators would be 12. Once you find your common denominator of 12, you're going to multiply 12 throughout the whole equation. In other words, you're going to take 12 and you're going to multiply it here and here and here. The reason you're allowed to do that is you multiplied on the left side of the equation by 12 and you also multiplied on the right side of the equation by 12. So that's why you're allowed to do it. But there's an easier way to think about these 12s. You'll notice that I'm multiplying all of the equations through by 12, and 12 actually means 12 over 1. So I'm multiplying all of the tops through by 12. So the easiest thing for me to do is to actually just put a 12 in every top. So when you put a 12 in every top, then each of those three fractions will reduce. So my first one is 12 times 3 over 4. Well, I know that 4 goes into 12 3 times. So what this term would actually leave me with is 3 times 3, which is 9. My next term is 12 times x over 12. So a 12 and a 12 would cancel out, and that would just leave me with x. My next term is 12 times 2 over 1. Well, that doesn't cancel out, so that just leaves you with 12 times 2, which is 24 over 1. Now, my fractions are gone, so that was great. So all I have to do now is get the x by itself. So to get the x by itself, I'm going to work on the x side. So I'm going to move 24. So I'm going to subtract 24 from both sides. In order to subtract them, I need to put the 24 on the top. 9 can't be subtracted from 4, so I have to borrow, and that makes that a 14. So 14 minus 9 would give me 5 with a 1. Now remember 24 was larger, so that means my answer is going to take a negative result. So my answer would be negative 15. My video is getting a little lengthy, so I'll pick back up fractions in the second part of the lesson.